What actually happens under the chassis when a truck drives over a speed bump? You can see the first wheel being pushed up, while the second wheel sinks down. These two wheels are connected by this central linkage, which distributes the truck's weight evenly between them. If you remove this linkage and fix the suspension, the second wheel would lift off the ground when hitting a speed bump, leaving the entire weight of the truck on the first wheel. This is the multi-link suspension system of a truck. Also, here is a leaf spring suspension system, mainly used to easily absorb minor bumps on the road. It is called a leaf spring because it is made of layers of thin steel plates stacked together. The top layer is the main spring, with holes at both ends to connect to the shackles and the chassis. The layers stacked beneath the main spring are called helper springs, all secured together in the middle with a U-bolt. The purpose of this structure is to support the vehicle's weight while absorbing bumps and impacts from the road. You see, when the wheels roll over speed bumps or potholes, the axle transfers the impact directly to the steel plates, which flex slightly to absorb that energy. Once the impact passes, the plates return to their original shape, providing excellent shock absorption and cushioning. Also, there is a differential here on the chassis, and its job is to transmit power to both wheels simultaneously. The reason a differential is used is that it increases torque while distributing different amounts of power to the left and right wheels. To give a simple example, when a truck turns, the inner wheel actually needs to rotate slower than the outer one. In this situation, the differential can perfectly perform its adjustment function. If we installed a standard solid axle gear here, the speed of the left and right wheels would be forced to synchronize, causing the inner wheel to experience excessive sliding friction, which leads to rapid tire wear. This is why a differential is absolutely necessary. Now, once the power leaves the differential, it must be sent to the wheels, and it has to pass through a special joint along the way, the universal joint. The universal joint not only provides stable power output while changing the transmission angle, but its length can also constantly expand and contract, which is necessary for the entire suspension system to function properly as it moves up and down. Regarding the multi-link suspension mentioned earlier, its purpose is to distribute weight evenly between the two wheels. So why can't I just use springs here instead? That really won't work, because standard springs are designed for specific loads. If you change the truck's load, you'll run into major issues. Suppose it's an empty truck. When going over a speed bump, the body is too light, so this spring doesn't get enough pressure to compress and rebound effectively. It acts like a fixed wheel, causing the second shield to lift off the ground, putting all the weight on the first one. It might barely manage when empty, but once loaded, the heavy body will completely bottom out the suspension. Then, when hitting a bump, all the weight will slam onto the second wheel, easily causing component damage or even a blowout. That is why this interconnected multi-link system is essential. Finally, let's look at the differential mentioned earlier. Look at this drive shaft. As it rotates, it drives the ring gear and the entire system. Inside, these two are the planetary gears, and the two connected to the wheels on the sides are called side gears. The movement of the planetary gears is quite unique. They not only revolve with the ring gear, but also rotate on their own axes. It is this combined motion that drives the side gears, delivering power to the rear wheels. When the truck drives in a straight line, both wheels rotate at the same speed. The planetary gears do not rotate on their own. They simply turn with the assembly, distributing power equally to both axle gears. But on slippery roads, when more power is needed to get unstuck, the planetary gears spin rapidly, concentrating power to one specific wheel. This is the core function of the differential. So when the truck goes over a speed bump, the multi-link system stabilizes the body, the leaf springs absorb the shock, and the differential distributes the power. Behind every seemingly simple action lies a sophisticated design.